In this problem, they're asking us to calculate the value of the equilibrium constant K for a reaction that includes gases. Conveniently, because all three substances are gases, their concentrations do belong in the equilibrium expression. The only maybe tricky thing is that they give you numbers of moles for each of the three substances and not their molarity. You need to find their molarity by dividing by the volume of 2 liters, because concentration or molarity is moles per liter. So let's start with just writing an equilibrium expression for this equation. It's product concentrations raised to the power of their coefficients divided by reactant concentrations raised to the power of their coefficients. So for instance, because of the coefficient 2, we put an exponent 2 for N2O in the equilibrium expression. And because of the coefficient 2 for nitrogen, we put an exponent 2 for nitrogen in the equilibrium expression. And because of the implied coefficient of 1 for oxygen, we have an implied exponent of 1 for oxygen in the equilibrium expression. Now, let's show work for finding the concentrations for each of these. We're going to indeed use the number of moles that they gave us in the problem for N2O, for N2. Oops. Okay, let's start over. For N2 concentration they gave us, or the number of moles they gave us was 2.8 times 10 to the negative fourth moles. But then to find the concentration, we would need to divide by the number of liters. And so that works out to be 1.4 times 10 to the negative fourth moles per liter, or molar. Next, for oxygen, the number of moles they provided us in the problem of 2.5 times 10 to the negative fifth, we will use and divide by the number of liters they gave us. And since everything's in the same flask, they'll all have the same volume of 2 liters. And so that gives us 1.25 times 10 to the negative fifth. And for N2O, they gave us 2 times 10 to the negative second moles, and we'll divide that by 2 liters and arrive at 1 times 10 to the negative second molar. We can plug those molarities into our expression for K. And once we crunch all of those numbers, we arrive at a final answer of 4.08 times 10 to the eighth. Don't be surprised if the values for K are quite large. That's common. So our final answer is 4.08 times 10 to the eighth, and there are no units for the value of K.